Welcome to 10.3 Day 2. These are our video notes continued from 10.3 Day 1. You don't need to have the essential question written down since you already have it from yesterday's notes. So the first thing that you are going to do from your textbook is you are going to cut out the chart that it says parts of an algebraic expression. It's on page 281. Go ahead and cut it out and you're going to glue it onto your notes here. And again, that's on page 281 of your textbook. Take your scissors, cut it out, and glue it in. That should be the first thing I'm seeing on your 10.3 Day 2 notes. Today we're going to talk about simplifying algebraic expressions and also collecting like terms. So you might be thinking, what is a like term? A like term has the same variable and same exponent. So an example of a like term could be 5x squared and 3x squared, okay? Those could be combined to make 8x squared, okay? 5x squared plus 3x squared equals 8x squared. Notice I'm not adding the exponents, I'm not adding the x's, I'm only adding the coefficient. That's the number in front of the variable, giving me 8x squared. So let's try an expression here. I'm going to simplify by collecting like terms again. I've got 6x squared minus 4x squared equals what? And same thing as I did above. The x squared and the x squared will transfer over into my answer. And I'm only going to subtract the coefficient. So again, that is the number in front of the variable. Go ahead and add that vocabulary word coefficient into your notes, the number in front of the variable. So I've already got my x squared. I'm just taking 6 minus 4, and I get 2. So my answer is 2x squared. Let's check out another one. I have 3a plus 2b squared plus 5a minus 1b squared, and I need to combine like terms to solve this. Now what I do when I'm combining like terms is I will put a box around the like terms that I need to combine and then circle the others. So kind of watch how I do that. I'm going to put a box around all of my like terms with an A. I've got 3a and 5a and they are both positive. And I'm going to put a circle around my other like terms that have a squared. I've got 2b squared, that's positive, and I've got negative 1b squared here. So I'm going to take my 3a and my 5a. I'm going to add them together. That gives me 8a. And my 2b squared minus 1b gives me positive 1b squared. Remember, when we're dealing with variables, you don't need to write the 1 in front of the variable. You could just leave it as 8a plus b squared. And we will know that there is an imaginary 1 in front of that b squared. So that is simplifying this long algebraic expression. Let's look at one where we get to use the distributive property. Let's try 3a plus 2 times the quantity of b plus 5a. Now I need to use my distributive property to distribute my 2 and apply it to the b through multiplication and also to the 5a. Take a look at this. 3a plus 2 times b is 2b plus 5a times 2 is going to be 10a. Is there anything that I can combine here? Yes, I can. I can combine 3a and 10a, giving me 13a, and I'm left with positive 2b. Again, I'm simplifying this algebraic equation. Let's try another one. 1y plus 11x plus 7y minus 7x. Collecting like terms again. This time they've given me a 1 in front of my y. If y was just there, we would know that the 1 is implied. So I'm going to put a box around my like terms. So I boxed my y's and I circled my x's. So I've got positive 7 and positive 1. Gives me 8y. Then I've got positive 11 and negative 7. So I can look at that like 11 minus 7. And I'm left with positive 4x. So again, simplifying this algebraic equation. You can make some of these up and solve them as well. What if I had an exponent that was cubed? 6x to the third power minus 3y plus 8x to the third power minus 2x to the third power plus 4y. So this looks like a super long problem, but we can simplify it easily. Go ahead and put a box around your like terms. I'm going to box everything that has x to the third power, also known as x cubed. So here we go. I've got an 8 and a negative 2, so I can subtract 2 from 8, which gives me 6x cubed, and I'm bringing down the rest of my problem. Showing my work step by step, and I have yet another x cubed to take care of. I've got a positive 6x cubed and another positive 6x cubed. Now I have 12x cubed minus 3y plus 4y. Now moving on to my like terms of the y's. I've got negative 3y and I've got positive 4y. Notice how I have attached the operation to the number to the right of that operation. For example, this minus is attached to that 3y and the plus is attached to that 4y. So I look at this like positive 4 and negative 3. So I can look at that like 4 minus 3 is 1y. And my 1 is positive. So it gets that positive sign. 12x to the third power. So my answer, simplifying this big long problem, is 12x cubed plus 1y. Okay. Let's take a look at our last example problem. Our last example problem is 4a to the fifth power minus 2a to the fifth power plus 4b plus b. Now, when combining like terms, I do like to take that 1 and put it in front of the b so I don't forget about it. Just so it doesn't get lost. Again, I'm going to start with combining like terms. Right away, I've got my like variable and my like exponent. So I've got 4a to the fifth power minus 2a to the fifth power. Leaves me with 2a to the fifth power plus 4b plus 1b. The next step is I need to combine my b's. Positive 4, positive 1 means I'm adding those together. 4b plus 1b is 5b. Okay, the b stays. We're not changing it into a squared because there's two b's. We're just keeping it as b. So 2a to the 5th power plus 5b would be your answer there. Go ahead and take care of the try this practice problems on the next couple of slides and be ready to work on 10.3 more tomorrow. Have a good night.